Hello everyone, welcome to Vision NEET IIT Academy, and today we will be discussing the part 2 of our one-dimensional motion, lecture 2 of our one-dimensional motion. Let us briefly see what are the topics that we are going to cover today. Okay, so this is the continuation of our class, motion in a straight line. Okay, in today's topic, we are going to cover mainly equations of motion, and we will see the applications of the equations of motion. These are quite important equations of motion, very important, and we'll see their application in numericals. A lot of numericals has been kept in the class purposefully to make you people accustomed with the numericals that may come in your examination. Okay. Apart from that, after that, we will be focusing on the analytical method. We will be deriving the equations of motions analytically, and then we are going to discuss the sign convention. Okay, what are going to be our sign conventions, which side we are going to take positive, which side we are going to take negative, okay, things like that, followed by displacement in the nth second, okay, calculus method. So it's like derivation only, deriving the equations of motion through calculus method. Then we'll discuss the free fall motion under gravity, followed by relative motion in 1D. Okay. Okay. Now, what is meant by uniformly accelerated motion? If I say that a body is accelerating uniformly, what is meant by that? What it means that, you see, a body is accelerating uniformly. It means that the acceleration of that body is constant. So what I can write here is A is equal to constant in this case, right? A body is said to have uniform acceleration if magnitude and direction of the acceleration remains constant during the particle motion. We all know that acceleration is a vector quantity. So we can write this. A vector is a constant. From this, what we can infer is the rate of change of velocity is constant. That means your velocity is increasing. Your velocity is keep on increasing, but it is increasing at a constant rate. Let us take an example. Okay. Let me give you an example. Suppose initially I have kept a body at rest. So its initial velocity is u is equal to 0 meter per second. Now I tell you that after every 1 second, its velocity is increasing, okay, and it is increasing by suppose 2 meter. So the velocity initially you will have is, you can say that, going by this example what I have given you, your velocity, initial velocity is going to be 0 meter per second, okay. This is our initial velocity, but after every second the velocity is increasing by 2 meter per second. So at time, this is at time t is equal to 0. At time t is equal to 1, what is going to be the velocity? u1. This is going to be 2 meter per second. So the velocity is keep on increasing at time t is equal to 1 second. Similarly, at time t is equal to 2 second, the velocity is going to be 4 meter per second. And this is at time t is equal to 2 second. At time t is equal to 3 second, the velocity is going to be 6 meter per second. Okay, t is equal to 3 second. So you see, every 1 minute interval, every 1 second interval, here my delta t is nothing but 1 second. Here also my delta t is 1 second. Here also my delta t is 1 second. So for every 1 second time gap, what I can say is that the velocity is increasing at the rate of 2 meter per second. So it's a uniform rate increase in the velocity. Okay. But since the velocity is changing, we are not going to say that this is a uniform motion. Because see, uniform motion means what? The velocity is uniform. The velocity should not change with time. But here I can say that the velocity is changing with time, right? From 0 to 2 to 4 to 6, likewise. So it is obviously not a uniform motion. So if you are having a constant acceleration, that is actually an example of non-uniform motion only. Okay. So for uniform acceleration, a is equal to constant, and for one dimensional motion with constant acceleration, we have certain equations of motion. And these equations of motions are v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as, and you see these are primarily my equations of motion. So I'll say that these are my equations of motion. 3 equations of motion we have. These are the 3 equations of motion. Okay. These are the main 3 equations of motion that we have. This is the displacement of nth second. We'll see what it means. We'll see that. Don't worry. But let us first focus on these equations. Okay. So if I write the equations, we have 3 equations. V is equal to u plus at. This is my equation number 1. S is equal to ut plus half a t square. This is my equation number 2. And v square is equal to u square plus 2as. This is our equation number 3. Okay. These are the 3 equations of motions that we have. What are the meanings of these equations? Okay. So here the meanings are, we can say v is nothing but final velocity, okay, u is nothing but your initial velocity, okay, t represents time, okay, a represents acceleration, okay, and s represents displacement. What is the displacement of the particle? That is basically given by s. Okay. Now we are going to see the derivations of these equations of motion. Okay. First, let me think about the first equation. So what we have in the first equation is v is equal to u plus at. Okay. This was my first equation. Now I am going to derive it. See, what we can say? We can say that acceleration is nothing but, okay, acceleration is nothing but del v, delta v, that means the change in velocity upon the change in time. Okay, this is only acceleration. when the delta t tends towards 0, okay, then we can say that acceleration is nothing but dv dt. This much we have seen. Okay. Now, if that is the case, then if my initial velocity is u and my final velocity is v, then what I can say my acceleration to be? I can say that the del v is nothing but final minus initial, so v minus u upon the time t. I can very well say that if it is from t is equal to 0 to t equal to t, I am calculating, okay, then I can say that acceleration is nothing but v minus u by t. Following this, I can say that v is equal to u plus at. So here comes your first equation which we have derived, right? So v is equal to u plus at. Now let us see the second derivation. Okay, so what is the second equation that I am having? The second equation is s is equal to ut plus half a t square, where they have their own meanings. I told you that s is nothing but the displacement, u is the initial velocity, t is in time, is the time, acceleration, a is acceleration. Okay. Now let us see. For this, what I would like to do is, okay, for this what I would like to do is, let us plot velocity versus time. Let us plot this velocity versus time. So this is velocity and this is time. Okay. Now suppose that at time, this is at time, so at time t is equal to 0, time t is equal to 0, a body is having some initial velocity, okay, and let that velocity be u. So what I can say is that the body is having some initial velocity which is u, this is u, okay, this is u at time t is equal to 0, and at time t is equal to t, this is t is equal to t, this is at time t is equal to t, okay, the body is having a velocity more than u, so it has gone something like this. So you can see from here. So I can say that this is nothing but, how much is this? Okay. Okay. Okay, I can say that this is v, this is my v, okay. So this much at t is equal to 0 is my initial velocity u, okay, at t is equal to t, my velocity is v, okay. Now very important concept I would like to discuss here. What is it? That is, this is a velocity versus time graph. In the, always remember, in the velocity versus time graph, the area of the velocity time graph gives you displacement. Okay, because you see, what is displacement? It is basically velocity into time. So if displacement is velocity into time, I can simply say that the area of the velocity time graph is going to give me the displacement. So if I ask you from this graph, okay, that what is the displacement that the body has covered from time t is equal to 0 to t is equal to t, then you will say that sir, this displacement is going to be, कितना displacement किया है body, तो आप बोलेंगे कि the displacement is nothing but the area covered under this curve, that is the area of, you can say, A B C, और इसको हम लोग अगर D बोलेंगे तो that is the area A B C D. Okay, now if that is the case, then let us see. This total area I can divide into two parts. I can divide the total area into two parts. One is, I can say the area ABCD is nothing but area of the triangle, not of triangle, or area of rectangle, let me take first, area of rectangle ABED plus area of the triangle DEC. Okay, this we can take. Now, what is going to be the area of this rectangle? That is going to be length into breadth. So that is going to give you, the length is nothing but t into u, right? The breadth is u, plus you see the area of triangle DEC. So this is nothing but half into what is going to be the base. The base is nothing but from t is equal to 0 to t is equal to t. So the base is t into the height. Now you see how much is the height? Height is nothing but CE. So this CE is nothing but V minus U, you can say. Okay. So this is V minus U. So this is going to give you S. Okay. And what is this V minus U? From equation number 1, from this equation, tell me what is V minus U? V minus U is nothing but AT. So I can write in this case, in case of V minus U, I can replace it with AT. So S becomes UT plus half AT into T. So you will get UT plus half AT square. Okay. So this is what you are getting. S is equal to UT plus half AT square. Okay. So we have derived the second equation as well. Now let us see our third equation. What is our third equation? Our third equation was V square minus U square is equal to 2AS. This was our third equation. Okay. Now we can say that V is equal to U plus AT. Okay. From the first equation we can say. So we can also say this like V minus U is equal to at, this can be said. Now if I multiply both sides with v plus u, okay, what I will get is v minus u into v plus u is equal to at into v plus u. Okay, we are getting it, right? So from here you can say that v square minus u square is equal to, okay, now you just focus on this part. यहां पे हम क्या कर सकते हैं अभी, we can say that displacement s is nothing but the average velocity into time. So you can say that it is v plus u by 2 into time, okay, where v plus u by 2 is the average velocity. So from here you can say that, okay, then v plus u into t is nothing but your 2s, okay. So this v plus u into t I'll now put as 2s a. So we have our third equation also, which is v square minus u square is equal to 2as. Okay. So now we will basically derive this by calculus method. Okay. So first and foremost, let us see again that what is the first equation of motion. This is nothing but we have discussed v is equal to u plus at, right? Okay. If that is so, how to derive it? Okay. So I can write, this is my equation of first equation. So okay, I can write from here that acceleration is nothing but dv dt, rate of change of velocity with respect to time. This is my acceleration. Then this can be written as a dt is nothing but dv. Okay. Now I am going to integrate both sides. Okay. From t is equal to 0, you integrate t is equal to t, and here you integrate from u to v, you basically integrate. So u to v. So what you are going to get is at is equal to v minus u. That means you have got it, v is equal to, I can write it here, v is equal to u plus at. So the first equation of motion we have derived by using calculus method. Okay. Please note this derivation. Okay. Now similar manner we will see the second equation of motion. Look for the second equation. Now if I talk about the second equation, what it is s is equal to ut plus half a t square. This is my second equation. Okay. Now, okay, I am going to derive it. So, I can write that V is equal to ds dt. Can I not write this? Just tell me. मैं लिख सकता हूं ना? That is, velocity is nothing but rate of change of displacement. S is the displacement, so it is velocity is nothing but the rate of change of displacement. I can write this. So then I can very well write this as well, that V dt is nothing but ds. This I can write. Okay, got it. Now, V, I am going to see what you need to have. We need to understand that also. So, our mind should always be active. The V is not there in this equation. S is equal to U plus AT. Finally, what are the things that we that are there, that are visible in this equation? U is there in the equation. Time t is there, so dt is going to give you that value. You are getting U, initial velocity, nowhere final velocity is involved in the equation. So, I will have to replace the V here. So, V I can replace by saying that from the equation number 1, V is what? U plus AT. So, you plus you just replace, in case of V you write U plus AT, okay, into dt is nothing but my ds. This I can write. Now you integrate, okay, you integrate from time t is equal to 0 to t is equal to t, and you integrate this from s equal to 0 to s, okay. Okay, so what you are ultimately getting is, it is u dt. So integrating u dt plus a t dt, okay, is equal to, here integration is only going to give you s. So if you integrate it, you will get ut plus half a t square, okay, that is equal to s. So s is equal to ut plus half a t square. So we have derived the second equation of motion by calculus method, okay. Now, last but not the least, I would like to derive the third equation of motion as well. So what is my third equation of motion? It's v square minus u square is equal to 2as. This is my equation, right? Okay. Now, I can say acceleration to be v dv dx. How? You see, what is v? Velocity. It is ds dt, okay. Velocity is ds dt. Now, this can be written as, I can write a to be ds dt into dv dx, okay. So if you write it, you are going to get v dv dx, okay. So I can write the acceleration to be v into dv dx. Now, if you integrate it, right? Now this side if I integrate from 0 to s, right, and this side if I integrate from u to v, what we are going to get is nothing but as is equal to v square minus u square by 2. Okay. So v square minus u square is going to give you 2as. So this is our v square minus u square giving you 2as. Okay. This is our third equation of motion. Right. Now let us solve a question. So you please read the question and then we are going to solve it. Okay. So it is saying that a body starts from rest with constant acceleration. So your acceleration is constant, a value is constant, and the body is starting from rest with constant acceleration. What is the ratio of the distance traveled by the body during the 4th and 3rd second? Okay. So here I would like to, for your examination purpose, I would like to give you a formula. You know, just to, if you anyway you can solve it by equations, it is coming from the equations of motion only. But remember that nth second displacement Sn is equal to u plus a by 2 2n minus 1. This is my displacement in nth second, right? So I can say where n is, what should I say, the time, means which second you are actually calculating it. Now, so keeping this in mind, if I say that you are being asked to, what is the ratio of the distance traveled by the body, 4th and 3rd. So S4, what it is going to be? S4 is going to be like u is equal to 0, the body has started from rest, and it is a constant acceleration. So let us take a by 2, this is constant. Okay. 2 into 4 minus 1. So you are going to get a by 2 into 7, right? And S3, how much you will get? A by 2, 2 into 3 minus 1. So this is going to give you a by 2 into 5. Okay. So now you see S4 by S3. S4 by S3 is nothing but 7a by 2 into 2 by 5a. So it is 7:5. So S4 by S3 is nothing but 7:5. This is the answer. So your answer is going to be option A. Okay. Now please think on this, whatever is written. If A is equal to 3t, can we use V is equal to U plus AT? That is the question they are asking. if A is equal to 3t. What does it mean? Let us try to get the implication of it. So they are saying A is equal to 3t. That means when I am considering t is equal to 0, at that time A value is becoming 0. When I am saying t is equal to 1, at that time A value is becoming 3. Okay. When I am saying t is equal to 2, at that time A value is becoming 6. When I am saying t is equal to 3, at that time my A value is becoming 9. So that means you see A is nothing but a function of time. So A is not constant. A is not constant. A is changing with time. But in these equations of motions that we are discussing here, they are for constant acceleration. So your A has to be constant to apply these equations of motions, because that is the first thing which I said in the class that the acceleration has to be constant or the acceleration has to be uniform. What it means is that it has to be independent of time. It is not changing with time. Then only we can use the equations of motion. So this concept, you please note it down. I would like you to write this very important concept with double star. The equations of motion can only be applied when acceleration is constant. Acceleration, that is the A value, is constant. What it means? That is when A is independent of time. Okay. So please note it down. Very important concept. Okay. Now please read this and we are going to solve it. Okay. So what it is telling? It is saying that a body is moving initially with 10 meter per second, okay, and is acted upon by a constant force. So it is a force is acting on this body, creating an acceleration, because of which acceleration is being created. Why? When force is applied, acceleration is going to be created. We are going to see in Newton's laws of motion. Okay. Now constant force creating an acceleration shown below. So you see here the direction of the acceleration and the direction of the velocity, they are the same. Okay. Initial speed they are asking. So initial speed has been given to you only. Initially it is 10 meter per second. So this you can directly write to be 10 meter per second. This is the initial speed. Nothing. Okay. Now motion is, obviously the motion is uniformly accelerated motion, because you see acceleration is constant here. A constant force is being applied. So whenever remember that a constant force is going to be applied, then your acceleration value is always going to be constant. Say for example, in case of if I drop this pen, something like this, then a constant force is applying downwards. that is the gravitational force. It is not changing with time. That is the mg, mass of this plane multiplied by the acceleration due to gravity g. Okay, so as it is not changing, the force is not changing, the acceleration is also not changing, it is constant, which is the value of g. Okay, 9.8 meter per second square. So motion is, you can write, uniformly accelerated motion. So we have this, right? Now velocity and displacement after 5 seconds. Okay. So velocity and displacement after 5 seconds. Let us first find out the velocity. So your initial velocity is, 10 meter per second. So your v is equal to, I am going to apply my first equation of motion. V is equal to u plus at. So you know the u value is going to be 10. Okay, u plus at. What is the acceleration? Acceleration is 2, right? And what is the t? T, they are talking about 5. Okay, so that means you have 10 plus 10, which is 20 meter per second. So this is going to be your velocity. This is going to be your velocity after 5 seconds. So after 5 seconds, your velocity is going to be 20 meter per second. Okay, and the displacement. Okay, let us now calculate the displacement. So displacement, if I would like to calculate, you can say that S is equal to ut plus half a t square. So u is how much? U is 10. T is how much? T is 5 plus half. What is the acceleration? Acceleration is 2. And what is the t? T is 5. So this is what we will have, 50 plus 25. So this is give you a value of 75 meter. So your displacement is going to be 75 meter. Please note it. Very important sum. Okay. Now I would like to you to go through this. अब जाइए एक बार पढ़िए इसको, उसके बाद हम लोग डिस्कस करेंगे. एक बार पढ़िए शांति से. ठीक है, बहुत इंपॉर्टेंट कॉन्सेप्ट है. 2-3 कॉन्सेप्ट हम लोग यहाँ पे कवर करेंगे, बहुत इंपॉर्टेंट है. व्हाट इज टॉकिंग अबाउट? अ बॉडी इज मूविंग इनिशियली विथ 10 मीटर पर सेकेंड. तो आपका इनिशियल वेलोसिटी कितना है? देखिए इस पे मत जाइए. इनिशियल वेलोसिटी ये v लिखा है, लेकिन यही इनिशियल वेलोसिटी है. ओके, इट इज, यू कैन राइट इट u as well. So a body is moving initially with 10 meter per second and is acted upon by a constant force. एक constant force act कर रहा है. तो मैंने पहले वाला सम में ही क्लियर कर दिया था फंडा कि constant force का मतलब क्या है? Acceleration is constant. Okay? It is acted upon by a constant acceleration. जहां पर भी आपको ये नजर में आएगा constant force, always remember वहां पे acceleration is constant. Okay. Creating an acceleration shown below. So the acceleration is shown below. So a is equal to, you see, 2 meter per second square. But here there is a fundamental difference between the sum that we did previously versus this sum. Here you see the direction of the acceleration is just in the opposite direction. Motion का opposite पे acceleration का direction है. मतलब क्या है? ये जो भी acceleration हो रहा है यहाँ पे, जो भी यहां पे एक्सिलरेशन हो रहा है वो क्या कर रहा है, दैट एक्सिलरेशन इज एक्चुअली ओके, इट इज एक्चुअली रेजिस्टिंग द मोशन। तो अल्टीमेटली क्या होगा, ये बॉडी सामने मूव कर रहा है लेकिन फोर्स एक्ट कर रहा है पीछे, तो अल्टीमेटली द वेलोसिटी विल कीप ऑन डिक्रीजिंग। ये वेलोसिटी क्या होगा, घटते चला जाएगा, घटता चला जाएगा, घटता चला जाएगा, जाते जाते एक वक्त आएगा जहां पे ये कंप्लीटली रुक जाएगा। ओके, इट इज गोइंग टू स्टॉप। So this is the situation. So initial velocity, they are asking the same question. Initial velocity is 10 meter per second only. Motion is, यहां पे आप क्या लिखोगे, motion is uniformly retarded या uniformly decelerated. That is what we, same चीज है, acceleration ही है लेकिन negative है ना, तो that is why we will call uniformly decelerated. Okay, time taken by the body to stop, बहुत इंपॉर्टेंट कॉन्सेप्ट है, कितना टाइम लिया है पूरा स्टॉप करने पे। तो कैसे निकाले भाई इसको, यू सी व्हेन द बॉडी स्टॉप्स, द मेन थिंग यू नीड टू अंडरस्टैंड इज, तब वेलोसिटी क्या है, जीरो हो गया, तो मेरा फाइनल वेलोसिटी क्या रहेगा, जीरो। Initial velocity given to you 10 meter per second, final velocity 0. Which equation you should apply? You also know the acceleration. So which equation you need to apply? You need to apply equation number 1. V is equal to u plus at. Let us see. यही हम लोग कर लेते हैं, जितना स्पेस है काफी है। Okay. So you see here, I am solving C. Okay. So you have V is equal to 0 meter per second, right? And you have U is equal to 10 meter per second. You have acceleration value given to you minus 2 meter per second square. Why I have taken minus? It is in the opposite direction of the velocity. Okay, now let us put it. V is equal to U plus at. So V मतलब 0 is equal to U, लेकिन प्लस A, एक्सिलरेशन इज हियर नेगेटिव ना, सो इट इज गोइंग टू बी माइनस एक्सिलरेशन कितना है 2, टाइम कितना है मेरे को पता नहीं है t, ओके, सो दैट गिव्स यू t इज नथिंग बट 5 सेकेंड। 5 सेकेंड में क्या होगा, 5 सेकेंड में ये बॉडी बिल्कुल रुक जाएगा। सो इन 5 सेकेंड्स द बॉडी इज गोइंग टू स्टॉप। ओके, सो दिस इज 5 सेकेंड एंड डिस्टेंस एंड डिस्प्लेसमेंट बिफोर द बॉडी स्टॉप्स। अब आपको पता है, टाइम भी पता है, तो डिस्प्लेसमेंट कितना होगा, एस इज इक्वल टू ut plus half a t square. From that you can directly find out s is equal to, u कितना है आपका given है ना 10, टाइम कितना है 5, माइनस होगा, क्यों माइनस होगा, क्योंकि एक्सीलरेशन नेगेटिव है। एक्सीलरेशन कितना है 2 टी स्क्वायर, सो मतलब 25, तो यू आर गोइंग टू गेट 50 माइनस 25, है ना। सो व्हाट यू आर गेटिंग, यू आर अल्टीमेटली गेटिंग 25 मीटर आपको मिलेगा। ओके, so this is going to be your 25 meter. अच्छा, और यहां डिस्टेंस और डिस्प्लेसमेंट एक ही होगा ना, क्योंकि ऐसा तो नहीं है कि बॉडी एक जगह तक गया उसके बाद वहां रुक गया, उसके बाद फिर से वहां से दूसरे दिशा पे आना शुरू कर दिया, तो मेरा डिस्टेंस डिस्प्लेसमेंट ऐसा तो कुछ नहीं है, तो यहां पे सेम है. ओके, नाउ यू सी दिस. I would like to, I'd like you to go through this question. ओके, तो यहां पे क्या है, देखिए बॉडी इज मूविंग इनिशियली विथ, सो इनिशियल वेलोसिटी आपका गिवन ही है 10 मीटर पर सेकेंड, इज एक्टेड अपॉन बाय ए कांस्टेंट फोर्स. कांस्टेंट फोर्स का मतलब क्या है जी, हमने बोला अभी, हम लोगों ने डिस्कस किया ना कांस्टेंट फोर्स का मतलब क्या है, कांस्टेंट एक्सीलरेशन. सो u is equal to 10 meter per second, acceleration you are going to put it constant, creating an acceleration shown below. so acceleration आपको given है, लेकिन सेम फिगर है यहां पे, वेलोसिटी का जो डायरेक्शन है, एक्सीलरेशन का डायरेक्शन जस्ट ऑपोजिट पे है. ओके, इट अगेन इंप्लाइज, क्या शो कर रहा है कि बॉडी जिस दिशा पे जा रहा है उसका फोर्स ऑपोजिट दिशा पे एक्ट कर रहा है. तो अल्टीमेटली फोर्स क्या करेगा, फोर्स उस बॉडी को स्टॉप कर देगा. कोई एक मतलब फाइनाइट डिस्टेंस कवर करने के बाद बॉडी इज गोइंग टू बी स्टॉप्ड. ओके, फाइंड द डिस्प्लेसमेंट इन फर्स्ट, सेकेंड, थर्ड, फोर्थ एंड फिफ्थ. तो यहां पे हम लोगों ने डिस्कस किया था एक फॉर्मूला डायरेक्ट. देखिए देखिए फॉर्मूला आपको कब काम पे आएगा, दैट इज द थिंग. ऐसा सवाल तो आप हम बहुत तरीके से कर सकते हैं, लेकिन डायरेक्टली इफ वी आर यूजिंग द फॉर्मूला, a lot of effort and time is actually going to be saved. So you see, हम लोगों ने डिस्कस किया था एसन, द डिस्प्लेसमेंट एट द nth सेकेंड. सो ये क्या था, u प्लस a बाई 2n-1. बस इसको आप यूज कीजिए. तो s1 क्या हो जाएगा आपका, s1 is going to be, the u is 10, okay, plus what is the a is here negative, so please keep it in mind. So it is not going to be actually plus. साइन को आप थोड़ा सा ध्यान से देखिएगा, ठीक है, और 2 into 1 minus 1, ठीक है. तो यहां से हम एक काम करते हैं, that is 10 minus, okay, 2 into 1 minus 1, what it gives you is 10 minus 1, 9, right? So S1 is 9. Similarly, you can directly say S2 कितना होगा, 10 minus तो सेम ही होगा, 2 into 2, so S2, yes, 2 into 2 minus 1, so that means 7. S2 7 हो गया आपका. S3 कितना हो जाएगा, 2 into 3 minus 1, ओके. और S4, सिमिलरली S4 कितना हो जाएगा, 4 minus 1, so you can say this 1, 8, no, sorry, this is 7, 10 minus, so it is 3. और S5 यही कर देते हैं. S5 क्या होगा, 10 minus 2 into 5 minus 1, so it is going to give you 10 minus 9, 1. So आपका S1, S2, S3, S4, S5 का वैल्यू रहा, S1 is 9, S2 is 7, S3 is 5, S4 is 3, and S5 is 1. Okay, so these are the values that you ultimately get here. Okay, now let us solve this question. The velocity of a body moving with a uniform acceleration of 2 meter per second square is 10 meter per second. Okay, its velocity after an interval of 4 seconds is. Okay, let us solve it. So they are saying that the velocity of a body moving with a uniform acceleration, so the acceleration is uniform here. So a is equal to, you have 2 meter per second square, and that is, see, nothing has been said here, means it is, we will take it to be the positive acceleration only. The velocity of a body moving with a uniform acceleration is, so u, your u is given as 10 meter per second. Okay. Now its velocity after an interval of 4 seconds is, the time period they have said it is 4 seconds, so they are asking you the velocity, that means the final velocity. इतना तो information हमारे पास है, they have given this much of information to us, so these are the informations that are given to you. तो यहां से हमको क्या करना पड़ेगा, हमको v निकालना पड़ेगा, तो निकालिए, v is equal to u plus at, u plus 80, कुछ नहीं है, सिंपल एप्लीकेशन ऑफ द फर्स्ट इक्वेशन. सो u आपका कितना हो गया 10, एक्सेलरेशन आपका कितना हो गया 2, टाइम कितना हो गया 4. सो यू आर गोइंग टू गेट 18 मीटर पर सेकेंड. दिस इज योर v वैल्यू, this is your v value. So v is equal to 18 meter per second. Okay, read this and then we'll solve it. ठीक, see what they are talking about, very important concept. A car is moving with a velocity of, so initial velocity of the car कितना रहा 10 meter per second. This is the initial velocity, can be stopped. Okay, so stopped means final velocity 0 by the application of a force, constant force. मैंने बोला था constant force का मतलब क्या है, acceleration is constant in a distance of 20 meter. ठीक है, 20 meter in a distance of 20 meter, 20 मीटर पे वो कार, that car is being stopped. अभी ये मेरा फर्स्ट पार्ट ऑफ द क्वेश्चन है, आपको क्वेश्चन रीड करना भी बहुत आना चाहिए. ओके कि कितना इंफॉर्मेशन गिवन है, यहां से हम लोग कैसे इंफॉर्मेशन को, हम लोग जो हमें चाहिए उसको हम लोग एक्सट्रैक्ट करेंगे, दैट इज ऑल्सो वेरी इंपॉर्टेंट. सो दिस इज द फर्स्ट पार्ट ऑफ द क्वेश्चन. सेकेंड पार्ट टॉक्स अबाउट इफ द वेलोसिटी ऑफ द कार इज 30 मीटर पर सेकेंड. ओके, अभी हम लोग लेते हैं कार का वेलोसिटी कितना 30 मीटर पर सेकेंड. इट कैन बी स्टॉप्ड बाय दिस फोर्स इन. ओके, मतलब कितना डिस्टेंस कवर करने के बाद वो स्टॉप करेगा. पहले हम लोग तो इतना कर लेते हैं कि लेट अस फर्स्ट कंसीडर ओनली द पार्ट 1, वॉट एवर इंफॉर्मेशन. सो फ्रॉम देयर आवर आइडिया वुड बी टू गेट द वैल्यू ऑफ एक्सेलरेशन. ठीक है, सो यू सी आपको क्या गिवन है, आपको गिवन है 10 मीटर पर सेकेंड. सो u वैल्यू इज बीइंग गिवन टू यू 10 मीटर पर सेकेंड. ठीक है, एप्लीकेशन ऑफ ए कांस्टेंट फोर्स a मेरे को पता नहीं है. ओके, v वैल्यू इज गिवन टू यू एज 0 मीटर पर सेकेंड. ओके, एंड a कुछ भी हो सकता है और a ही हमको एक्चुअली निकालना है, और a's वैल्यू is basically given to you as 20 meter. Okay, so you have these informations. Now with these informations what you can do is, these informations you have, now what you will do, you will apply the third law, v square minus u square is equal to 2as. ठीक है, so v is 0, we can say is equal to u square. u का वैल्यू कितना है? सो इट इज 100, 10 स्क्वायर। माइनस, माइनस क्यों होगा? क्योंकि देखिए स्टॉप्ड, सो देयर इज रिटार्डेशन। 2, एक्सेलरेशन मेरे को पता नहीं है, एस तो मेरे को पता है ना, 20। So from here you can say that 100 is equal to 40A. तो A का वैल्यू कितना हो जाएगा आपका? 100/40. That means the A value is going to be 5/2. So this is the value of the acceleration that actually you are getting. So acceleration का वैल्यू कितना है आपका? 5/2 मीटर पर सेकेंड स्क्वायर. This is the value of the acceleration. You can write it. ठीक है. Now this acceleration is the same. Now here the velocity of the car in part 2 we are moving. It is 30 meter per second. It can be stopped by this. अच्छा, अब हम लोग क्या करेंगे? So here again we need to apply. में काम करते हैं. We are going to, just a minute. So here I have like the velocity of the car is 30 meter. So you please consider in my case, second case, u is equal to 30 meter per second. Okay, this I have. What information else I have gathered? A is equal to 5/2. Okay, and this should be negative also. Okay, please say A is equal to minus 5/2. So acceleration is minus 5/2 meter per second square. Okay, V is equal to 0. Because it is stopping, we need to find out S. So S, if you find out, it is like V square is equal to U square minus 2A into S. Okay, so you will get 900 is equal to 5S. So S का वैल्यू आपको मिलेगा 900/5. So you'll get like 180 meter. Finally the car is going to stop at 180 meter. ठीक है, ऑप्शन सी. It is option C. Now see, please read this and then we would see how to solve it. Okay, let us solve this sum. A particle starts moving from rest state along a straight line under the action of a constant force and travels a distance of x in first 5 seconds. First 5 second पे वो x distance travel किया. The distance traveled by it in the next 5 seconds will be, okay. So what we need to do here is, see, we know that S is what? S is ut plus half a t squared. Here u is 0. So half a t square. ठीक है. So first 5 second के लिए क्या होगा? S5 is going to be half into a into 25. Okay. And that is equal to x. So I can say that 25/2 of a is equal to x. Okay, this is my x, or a value I can write, a value is nothing but 2x by 25. Okay. Let us keep it aside. Now, S5 we have calculated. Now, S10 is going to be ut, half into acceleration into 10 square, 100, right? So, that is going to be in the next, travel by it in the next 5 seconds, yes. So, this is going to be 50A, okay, S10. So, S in the next 5 seconds is nothing but, okay, 50A can also be written as, this 50A I can write like, हम ये करते हैं यहाँ पे तो सिंपल हो जाएगा. 50A को हम लोग ऐसे लिख सकते हैं कि 50A इसका मतलब है 50 इंटू A का मतलब है 2x by 25 है ना. तो you calculate that is going to be 4x. So S10 is your basically 4x. So you have got the value of S10. ठीक है, you have got the value of S10. So S in the 5th second, S in the last 5 seconds, that is going to be equal to S10 minus S5. Okay. So S in the last 5 seconds is going to be equal to S10 का वैल्यू है 4x और S5 का वैल्यू आपका कितना है x. So your answer is going to be 3x. Okay. Now there is another sum. Please read it. Okay. So it says a car moving with a speed of 50 km per hour can be stopped by brakes after applying brakes after at least 6 meter. ठीक. After 6 meter it is stopping. If the same car is moving at a speed of 100 km per hour, if the same car it is moving at a speed of 100 km per hour, the minimum stopping distance is. Okay. Here I need to discuss a very important point. What it is? So please understand, stopping distance is proportional to speed square. Just if you remember this point, half of your effort is basically reduced. Let us keep it like this. See, so stopping distance is proportional to speed square. क्योंकि अगर स्पीड ज्यादा रहेगा तो it is going to take more time to stop, right? Now let us see. So 6 meter, so I can say that 6 meter was my first stopping distance. Okay, I can say that this is proportional to, it is proportional to 50 square. Okay, and when the same car, so I don't know what is the distance when it is stopping, but the speed I know na, it is right. So from here you can say that, okay, d by 6 is equal to okay. Right. So this is becoming 4. So your d is ultimately becoming 24 meter. So you see your d value that you are getting is basically 24 meter. Okay. The initial velocity of a particle is 10 meter per second and its retardation is 2 meter per second square. The distance moved by the particle in the 5th second of its motion is. Okay. So distance in the 5th second of its motion. Okay. So they want to find us. Okay. So we can take it by the approach of s is equal to ut. So if it is 5th second, so s is equal to ut plus half a t square. So you can very well say that s5 ut, what is the u? So, or let us basically look at this in this way. Sn is basically how much? U plus a by 2 to n minus 1. Okay, that will be better. So you see S5, 5th second, U is 10, it is retardation minus 2 by 2. Okay, in the 5th second, 2 into 5 minus 1. So you get it 10 minus 9. So that means 1 meter. Okay. Now we will be discussing a very important concept. And what this concept is going to talk, in this concept we will see free falling, that is the motion under gravity. Free fall का मतलब क्या है? That we are basically kind of, just leaving something under the action of gravity. Say for example, if I say that, suppose this is a tower, okay, and from the top of this tower, okay, we are leaving a particular ball, we are dropping a ball. This ball is being dropped from this tower. Okay, so certain things we need to keep here in mind. Okay, what are these things? First and foremost, when, always remember, when the velocity, see you are dropping it na. So initially what was the velocity before you drop? U is equal to 0 meter per second. Okay. Now if I ask you that what is going to be the velocity when it is going to reach the ground, that is just, this is the ground, you understand, this is the ground. Now you, if the height of this is given to you like h, इसका height आपको given है h, तो आपको पूछा जा सकता है कि इसका just before dropping, just before striking the ground, tell us the velocity v. v कितना होगा? तो you need to understand that g is always working. G always works in this direction. This is the direction of my G. नीचे ही तो ना work करेगा G. Always G is going to work along in the downward direction. Okay, gravity. तो यहां पे अगर मेरे को V निकालना है तो we can use the equation 3 to find out the V. That is V square is equal to U square plus 2G H, because AC is here H. तो मैंने प्लस क्यों लिया? That is very important. Plus I have taken because you see the G value is basically assisting. It is increasing my velocity ना. मोशन जिस डायरेक्शन पे है उसी डायरेक्शन पे मेरा G का वैल्यू भी है. Okay, so that is increasing my speed every moment because it is assisting my motion. So that is why. Now this U initially, मैंने तो rest था ना, rest था ball. The ball was at rest. So initially the U value is basically 0. I can put here. So V square you can say is 2GH. So V final is equal to what you get is root over 2GH. So this is a very, very important, we can say, conclusion that I have drawn, we have drawn, come across. That when you are basically, when you are throwing something, okay, with initial velocity 0 and the height h, okay, it is having a height of h, then what is going to be the final velocity of it before it strikes the ground? It is always root over 2gh. You please note it down. Okay. Another thing that we need to understand here is the time. Time can also be asked to you. Like kitna time lagega? Like they can say that how much is the time? This is the, I can write here, this is the final velocity before striking. Right? Final velocity before striking. Now what is going to be the time? Time, how much time it is going to take? So if we calculate, then AC is equal to UT plus half AT square. That equation we will take. S means H here. So H is equal to UT is 0, half G T square. T square though we don't know. Okay. So my T square becomes 2G, sorry, not G, 2H by G, है ना? T square, 2H by G. Yes, T becomes root over 2H by G. This is the time taken. If you know the height, if you know the G, just you can directly simply calculate the time. Okay. Now let us solve this question. If a body, what it is saying, if a body is launched with an initial speed of 20 meter per second, what is the maximum height it will reach? Okay. Now here you see, when they are talking about that it is launched, launched means उसको फेंका गया है. लेकिन launch means क्या? Launch means ऊपर की तरफ फेंका है. Something like this, you see, this pen, I am throwing up. So after I throw up, so initially I am putting some velocity on this pen, है ना? But it is like going up, moving up and up, but because my gravity is downward or g value is downward, the velocities keep on decreasing at each and every moment. It is becoming zero after some height. Okay, they want us to know that height only. So here let us see. So suppose this is the level from where I have lifted it up, okay, the body. So this is the body, this is the body, okay. Now initial velocity u is equal to 20 meter per second. This is u. Obviously when it is going to reach a maximum height, यहाँ पे क्या होगा, the final velocity is going to be 0. फिर क्या होगा, ये फिर से वापस आएगा. That I am not considering. We are not interested in that. We are interested in finding this height. This height value h, we are interested to find out the value of this height. So you can just apply the third equation which talks about v square, that is 0 is equal to u square माइनस, अब माइनस क्यों होगा, वेलोसिटी किस डायरेक्शन पे है, इनिशियल, जस्ट लुक एट इट, इट इज अपवर्ड, लेकिन g किस डायरेक्शन पे है, डाउनवर्ड. ओके, सो माइनस 2g, ओके, g वैल्यू यू कैन टेक 10 ही कंसीडर कर लेते हैं, माइनस 2g into h, or let us consider g only. Okay, let us not consider it 10, I'll consider it g only. Let us say it is g into h. ठीक है, तो ये क्या हो जाएगा, कितना हो जाएगा, that means 400 is equal to 2gh. हो गया ना. तो h का वैल्यू क्या हो जाएगा, 200 by g. This is going to be my h value. Now you see, if you take g value to be 9.8, that is going to be something greater than your 10 value, 10, okay, greater than 10 you will get. But if you exactly take the g value to be 10 meter per second square, you are getting, sorry, greater than 20 you will get. So if you take the g value to be 9.8, the answer is going to be, h value is going to be somewhat greater than 20. But if you take the g value to be 10, then your h value will come exactly 20 meter when g is equal to 10 meter per second square. Okay.